Hello students, welcome back to the session. In the last session, we were discussing about the chemical properties. We'll be continuing from the same thing again. So thermal decomposition, I've already told you all what is thermal dissociation. Okay, you can just refer to the previous video to know about it if you don't. Okay, next we talk about reaction with metals. I was explaining you the same thing when the meeting got ended, right? So what is the reaction with metals? You have already must be knowing from the chapter acid, bases and salt that acid reacts with active metals to give us what? Metallic chloride,
Hydrochloride
metallic plus
with
hydrogen, isn't
Hydrogen.
it? So that is the same thing we'll be getting here also. Okay, so basics needs to be very clear in both the chapters. So we'll be taking HCl because HCl is what? HCl is himself an acid. So we'll take HCl plus any metal. We'll do what? M will go and displace Cl. H. Okay, M will go and displace H. So we'll get MCl plus H2. Okay, that's all for this. So next, we move on to the next thing, reaction with metallic oxides. So as you can see in the PDF, it's written reaction with metallic oxides and hydroxides. We get what? We get MCl and H2O. Why we are getting H2O instead of H now? Because say in hydroxide, oxygen is also present. So there's full, chances of forming water. How? We get HCl. And let's take any metallic hydroxide. Let's just write it as MOH only. Okay. So metallic hydroxide like this. Okay, MOH. So what we'll be getting? First of all, M will displace Cl, so we'll get NCl. Okay, plus now how many H's are there? One H. Okay, here is the second H of HCl, and we are having one oxygen also here. So what are the chances of formation? The
H2O
chances is H2O.
water.
Okay, so that is just very easy. Okay, so that was all. Next, we move on to the reaction with basic salts. So now this is not, this is not we don't have a standard equation for this. This depends on the basic salt. So we'll be now studying that. So let's start with it, guys. I hope that everybody has understood so far. Yes. So let's just, yeah, let me just delete this thing and let's start. So we are starting again with the same. So first of all, we'll discuss everything we are now in a very detailed manner. Okay. So first of all, we did what? We did metals, right? So what is the reaction with metals? So let's start with it. So reaction with metals. Okay. Reaction with metals. So let's see. Reaction with metals, how does it happen? I've already told you all. M plus HCl gives us what? MCl plus H2. Okay, that the same thing will be happening. Let's take any metal. Let's take sodium as the metal and HCl. What we'll get? We'll get NaCl plus
NaCl
H2.
plus H2.
Let's take the another. Let's take another one. So if I take, let's say we take magnesium plus HCl, we all know that we'll get Mg.
MgCl plus H2.
Okay, that was all. So now reaction is so high that the temperature during increases and H2 itself catches fire. Okay, so you have to note this, that in these both cases what happens, the temperature is so high, temperature is high, so H catches fire. Okay, H catches fire itself and forms what? In it burns in oxygen. H burns in oxygen to give us what? H2O. That means water vapors will be formed. Okay, so at last what we'll be getting? At last we'll be getting, if I talk about the example again, then we'll be getting NaCl plus H2O only, because at last it is burning into burning in air that is in oxygen to give us water. Okay, I hope So I'll be just erasing Sag plus H2, and this H2 will burn in. So write it in a very short form. Write it here. This will burn in O2 and give us what? Give us what? H2O. Understood, guys? I hope that it's very, very clear to everybody. So we'll get H2 and O. Okay, let's now move on to the next topic. So next we'll talk about its reaction with basic salts, which I said now that it depends on the salt we are using, because I've told you all in the chapter analytical chemistry that salts can be of various types like nitrite, sulfides, carbonates can be there. Yes or no? Sulfides,
Yes,
bisulfides,
sir.
sulfides, right? Many are there. So let's discuss. So I hope that everybody must be knowing that in this type of reaction, which we discussed just now, what will happen? Any metal which is below hydrogen in the reactivity series will show no reaction. Everybody might be knowing that now. I don't need to tell you all that. That if any metal is below hydrogen, so it will not form. Okay, like if I tell you the example of zinc, so zinc is below, isn't it? If I tell you the example of platinum or gold, so will it form gold chloride?
No,
Have you ever heard the name? No, it will
no.
not. Okay, because it's below the reactivity series. Now that was all. So let's now see the reaction with salts, which I said at the last, right? Reaction. Okay, this pen is not working properly. Why? So let's now start. Reaction with basic salts. That means bases. Okay, basic salts. More number of hydrogen is oxygen is there. Okay, so let's take the first example. Let's take the first example of carbonates. I told you all many are there. So let's first take the example of carbonates. So in carbonates we are having how many? So I'll just directly jump onto the reaction. If I have carbonates and if I add HCl to it, what will I be getting? I'll be getting salt. A salt I'll be getting, right? I'll be getting a salt plus I'll be getting water plus I'll be getting carbon dioxide, because carbonate is there na. See what is happening. This is what, this is a basic salt. Okay, that means this salt is having some base. And tell me, what does base form when it reacts with an acid? Acid plus base gives us what? Salt and water. That is
Salt
the
and water.
precipitation we are getting, salt and water. But this is having carbonates, that means it's having carbon also, so it will give us carbon dioxide for sure, right? Because it has it naturally. So if I give you some examples, then the examples can be, just give me a minute, guys. Tell you some examples also. Okay, so the examples can be Na2CO3, okay, plus HCl, okay, and it will give us what? It will give us
NaCl
Cl
plus
plus
H2O
H2O
plus
plus CO2.
CO.
Now many of you must be thinking that what will be the salt. So to get the name of the salt, now you can just first write water and carbon dioxide, and then you can just predict the name of the salt yourself. I'll tell you an example to do that method. Okay, let's take another salt. Let's take bicarbonate this time. Okay, let's take a bicarbonate. Let's take calcium and bicarbonate. So CaHCO3 whole
CO3.
twice plus HCl will give us what? Will give us, I'll just write carbon dioxide because we
CaCl.
get it for sure. We get water also because we'll get it for sure. Then what will be the salt? Now you can just see
CaCl.
here that we
Calcium.
have used this. We have not used the chloride and we have not used the calcium. Everything else we have utilized. So yes, we'll be getting the same thing, Ca and Cl into, okay, calcium chloride. Next we move on to the next type of salt, that is sulfides. So sulfides, I'll directly jump onto the equation. Sulfides plus HCl will give us what? It will give us salt and water. That means we have basic salts na. So that is why it's giving us salt and water. It's happening like a neutralization reaction only. So salt plus water plus what? Here we are having
Sulfate.
sulfides.
Hydrogen sulfide gas.
We are having sulfides. See, now here is a hidden truth. So what is there? In everything else, we were having oxygen, right? We were having oxygen. So the H of hydrogen chloride and the oxygen of the compound were forming water. But here in sulfides, is oxygen present? No, it's not present. So we'll not get H2O. Instead, we'll get H2S, because in this, water is not present. So let's see an example. Let's take the example of Na2S, that is sodium sulfide, Na2S plus HCl will give us what? A salt, that
NaCl
is
plus
HCl
H2S.
plus H2S. That is hydrogen sulfide. And you all must be knowing now, all must have rectified it. What is the smell of hydrogen sulfide?
Protonic
Rotten
smell.
egg smell.
Yes, this is known to us. Rotten egg smell. Okay. Next, we move on to the next type of salt. That is, let's talk about sulfides. So don't get confused between sulfides, D wala dog, and sulfides, T wala tiger. Okay. So there's a huge difference between dog and tiger, right? Sulfides and bisulfide. So let's look at an example. So first of all, the sulfides and bisulfides will react with HCl to give us what? To give us salt. It's having oxygen, so it will give us water also, and it will give us SO2. That means disulfide. Understood? So let's just separate this reaction because it's looking like it's one. So let's look at an example. In the example, we can take any sulfide. If you want to take, you can take sodium sulfide, because we are taking the example of sodium multiple times. Na2SO, what will it be? Na2SO.
3.
Yes, 3. Don't write 4 in examination, because many of the students have Na2SO4 on the tip of their tongues and they write it there. So Na2SO3 plus HCl give us NaCl plus H2O plus SO2. Okay, next, let's see, look at one more example. Let's take bisulfide. Okay, so let's take a potassium bisulfide. Na. Okay, let's take sodium bisulfite only. NaHSO3. Okay, and NaHSO3 plus HCl will give us. You can just, if you are not sure about the salt, then you can first write SO2, then you can write H2, and then whatever is left, NaCl is left there, NaCl. Okay, that was all. So this page is filled. Now let's move on to the next page. I hope that everything from this page is clear to everybody. See, your notes should also be like this. If I show you my register, or someday I'll show you all, it's also the same. I'm making colorful notes from my childhood. Means colorful is very nice, right? We are very interested in reading all these. So let's move on. So let's look at them. Let's look at the next type of salt. Let's talk about nitrates now. Nitrates is also a salt, yes. Let's talk about nitrates now. No discrimination. So 4 type of salt is nitrates. So nitrates plus HCl will give us what? It will give us nitrate.
Like uh,
What will it give? Tell me. Yeah, tell me. Joshua, anyone who was telling now? What will we get? There will be no reaction. There will be no reaction with basic salts. Nitrate will not react, but a few exceptions are there. So let's talk about those exceptions. Okay, a few exceptions are there. Let's talk about those exceptions. Okay, so we have a few exceptions like lead nitrate. You all must have heard the name before. So PbNO3 whole twice plus HCl will give us what? It will give us
CbCl2
uh,
plus
yes,
HNO3
very good. Plus plus
plus H2.
no, nothing. You are correct. Okay, this will be an aqueous form. Okay, so that is all. Okay, it will give us HNO3. HNO3, very important. Okay, next one more example. Let's see. Let's take AgNO3. AgNO3 whole twice plus HCl will give us what? AgCl2
AgCl2
plus
plus
HNO3.
HNO3.
Same goes with with mercuric nitrate. Hg2NO3 whole twice plus HCl will give us the same thing. What?
Hg2Cl2.
Very good. Hg2Cl2 plus HNO3. This has been asked in the examination that what is the color of this, so you can just write it is a white white precipitate. And yesterday one of my student called me and said that what will it, the color of this be? I've got this question in a question bank. This answer will also be a white ppt. Okay, and these all are precipitates. So very important. If you lose this precipitate mark, na, this symbol which is there, then you'll lose 1 mark in ICSE. So don't make any chance of losing that. Okay. Let's move on to the reaction with bases. Okay. So how does it react with bases? I've told you all NaOH. Let's take plus HCl. What will it do? It will give us what?
Salt and
NaCl
water.
plus HCl. That means this is what? This is neutralization. Okay, reaction. So this is neutralization reaction. Okay, now that was all for this. Now let's move on to the next part of this chapter. So now we'll be moving on to the preparation of hydrochloric acid. Okay, so in every different book it's given differently, so I'm just giving you a standard one. So this is a diagram which shows the laboratory method. Okay, this is a diagram which shows you all the laboratory method in which we are having a conical flask, as you can see. Okay, which is connected to a pipe. Okay, you all can see there's a tube which is connecting, and this tube is leading in to a beaker. As you all can see, this is a beaker to which tube they're leading it to. Okay, then next, what is happening? So I'll just draw the diagram with you all. So this is a setup. This is a conical flask to which there is a thistle funnel that is attached. Here's the thistle funnel. I know that everybody must be thinking this is not a thistle funnel, but I've not drawn the perfect one. But I know that everybody knows what is a thistle funnel, right? Then we have a tube which is leading into another beaker. Here's the beaker. Okay, and then there's another tube which is going on from this beaker to a next tub or a trough or a big beaker, as you all can see, and it's having a conical flask inverted, okay, towards itself. Okay, so let's now see what is there inside them. So in the first one, this is the solution in which we are having NaCl, that is salty water. Okay, salty water, now it's just molten NaCl. Okay, here is the cork. As you all can see, it's the cork. This is the thistle funnel upstairs, and there is what? There we have got H2SO4. Okay. Next, we have this beaker also, in which what is there? H2SO4 is there again. Okay. And here HCl we get. At last we get HCl. Let's see what is happening. Okay. So what is happening? First of all, I'll tell you the process. Please follow the diagram and you'll understand everything. Okay. Now, firstly, H2SO4 reacts with NaCl. So let's write the equation only. So what happens here? NaCl plus H2SO4. How does H2SO4 come? From this thistle funnel, the H2SO4 drops into the NaCl and it forms what? H2SO plus NaCl gives us Na2SO4. Okay, Na2SO4 plus HCl, and it will give us what? It will give us Na2SO4 plus HCl if the temperature is above 200 degrees Celsius. Okay, so here what's happening? Here the temperature is above 200 degrees Celsius. If the temperature is below 200 degrees Celsius, then we'll be getting sodium hydrogen sulfate, that is NaHSO4. There will be an addition of H there. Okay, now see, here we have got this HCl, as everybody can see, we have got this HCl here, right? So now the HCl gas evolved is passed again. Now here the HCl gas is evolved like this. It's evolved, yes or no? So when the HCl evolves, it goes into this tube and then goes inside the next beaker. In the next beaker, there is again H2SO4. Okay, so why is it going to H2SO4 again in the second washer bottle? Why is it going? Which is because H2SO4 is an excellent dehydrating agent. Dehydration means taking all the water from inside it. Okay, so the dried HCl gas, the HCl gas which was here was having some liquid, some moisture in it. It goes into H2SO4 to get dehydrated, to lose every moisture from inside it. Now the dried HCl again starts its journey from here. It gets dehydrated and it goes from here, and then finally comes here. Then in the beaker 2, now here see, if the beaker 2 is empty, means there is nothing inside this beaker. This is beaker 2. Okay, if this beaker 2 is empty, if there is nothing inside it, then we'll get what? HCl gas we'll get, because here what is coming? HCl gas is there. But when we have any water filled inside it, then we'll get what? Hydrochloric acid. We'll get liquid acid. Understood? If there is no water, then we'll get hydrogen chloride, that is gaseous hydrogen chloride. Yes, if there is water, then we'll get liquid HCl, that is hydrochloric acid. Okay, now there is a question that arises, that for dehydrating we can use some other dehydrating agents like CaO. Okay, so other dehydrating, other drying agents can be used like P2O5, that is what? Phosphorus pentaoxide. Okay, and calcium oxide can also be used. But why isn't it used? So the answer is that when it reacts with HCl, it reacts very strongly and doesn't, and gives us a completely different compound. Can you see? It's giving us a completely different compound. Are we getting HCl here? No, we are not getting. So that is why we use H2SO4 as a drying agent. It's a very popular question. Okay, because you will write that other dehydrating agent like phosphorus pentoxide and calcium oxide reacts with HCl to form different compounds. Okay, now to identify a gas, to identify the gas, if it is HCl only, what happens? We do what? We take a glass rod. Okay, we take a glass rod. If I just draw it, this is the glass rod which we have taken. Okay, let's see that, let's say that this is the glass rod, and we'll dip it into NH3. So when we'll dip it into NH3, what will happen? NH3 will be now present on this glass rod. Understood? Now, and we'll bring it near to the funnel where the HCl is coming, where the dried HCl is coming. So the dried HCl will come and react with this NH3, isn't it? It will come and react with this NH3. So what we'll get? We'll get white fumes. We'll see, yeah, we'll see white fumes coming. Okay, of NH4Cl, that is ammonium chloride. Okay, white fumes of ammonium chloride. So that was all regarding HCl. Okay, next we move on to what if we add water to the beaker. Okay, what if we add water? So in the last beaker, in the beaker number 2 which I've made now, this was the beaker number 2, and here was the tube coming through which HCl was coming, and here was the funnel, isn't it? What if I add water inside it? what will happen? So we'll see this mechanism now. Now, when the large beaker contains water with an inverted funnel, we'll get HCl in aqueous solution. So the preparation occurs as this. I'll tell you now how does it occurs. So first of all, what happens that this funnel was coming here, the HCl is coming in this direction. Here is the inverted funnel. Okay, what will happen? This is the beaker. Okay, and let's say that here is the funnel's mouth. Okay, and here is water, the water. Okay, so now as you can see that the beaker which is there, the inverted funnel, it is placed where? Is it dipped inside the water? Is it dipped inside water? No, it is not dipped inside water. It is where? It is at the rim of the water. Can you see that? It is at the top of the water. It's not dipped inside. It's just touching the top surface of water, isn't it? Now, what happens? Because of pressure, what happens? This water goes inside. Understood? This water goes inside and gets accumulated here at the neck. Okay, and then it reacts with the HCl which is coming from above and forms HCl in aqueous solution. What will happen? Then what will happen? Because of this, because of this, a gap is formed. Okay, outside the funnel, because of this back section, it is called the back suction. Okay, this is called what? This is called back suction. Okay, due to this back suction, there is a gap which is maintained. Like if I tell you how it is done, so there is the beaker again, and here's the inverted funnel again. Okay, so as you all can see, now the HCl is where? HCl, the water has gone up, the water was touching the rim, the rim was just here na, but now all the water has gone inside. So water is now inside it. Let's say that this is yellow water. Yes, and here a gap is maintained. Can you see there is a gap, isn't it? So since HCl is highly soluble in water, the delivery tube contains the delivery tube is directly giving HCl. Understood? That was all. Again, after some time, all of this which has been found again get inside. Again, the bag section occurs. Again, it goes down. Again occurs. Again goes down. The cycle continues. If you have not understood, you can just watch the video again and you will understand it. Read the text from your book. It's very important. Now we come to the end of this chapter. Thank you for watching. Please like, share, and subscribe to my channel. Please share it amongst your ICSE friends and appreciate my efforts. Thank you so much for watching. Happy learning.